morning. Welcome back to business math class. We're going to spend the day talking about wages and salaries, but as we begin every class, we're going to answer any questions that anyone had over the topic that we discussed in class. Someone's got a question already? Yes. Number 5 on the homework on page 54, 2.4, number 5. Yes, that's one that someone pointed out at the end of class we hadn't done an example like, and I meant to do one of those this morning. So let me move this. It works very similarly, got to find the top of my page here, to the problems that we did. We've got an old, change, new model. And when we worked homework at the end of class, someone asked about this one. We're going to always begin by setting it up with old, change, new down the middle, percent and dollar signs on either side. In number 5, it says the change was a decrease, and it was 57%, and that amount of change was $84.10. What we want to do is be able to complete the rest of the diagram. Is there another piece that we know we can put on our diagram? That's right. We always start by putting 100 by old. When we know that that change was a decrease, is there a way we can calculate the percent for new? Sure. We're going to subtract. We're going to go 100 minus 57, and what number are we going to get? I didn't do a very good job of hooking it on. Where do it? Would it be better here? Hold on. Got to get dressed again. I'm going to let you hook it this time. Maybe I didn't do a very good job. I didn't even notice it fell. So would it be easier on my shirt? I mean on my sweater? Okay. We now have everything we can do without making some calculations. We want to come up with both the old and the new when we have the change. What we're going to do is set up two proportions. 100 is to 57. I'm using line 1 and line 2. Does that make sense? I'm going to take the 100 is to the 57, proportionally the same as, I'm just ignoring.
You're solving for the base, aren't you?
The base is the old.
But you've got to equal 10 on the bottom.
Okay. In a proportion, I have a fraction that says two quantities that are fractions are equal. Okay? The 100 is you're going back to the percent problem where we had rate is to 100, proportionally the same as part is to base. We can work these proportions as long as they're set up proportionally without having the base on the bottom. Okay. All we do is ignore this bottom line. Is that all right? What I'm going to do then is go 57x equal 8410 times 100. I'm doing this not with the percent proportion, but with just the proportion that I get by having 3 of those lines. Okay, I'm going to talk to you about a couple of other things in a minute. We're then going to divide by 57, divide by 57, x equal, and I do have my calculator right here. We end up saying the old price is $147.54. Fran, does that make sense? Okay, let me tell you something else we can do with that one. You've turned it all around? Well, that's how come we get together. Yes?
It might help if you say that the decrease will go on the bottom and an increase will go on the top of the fraction of x.
Oh, not necessarily. That's not true. And let me give you, Christine and both. Let me show you another way we could set this up. I can put the 57 is to 100. If you want to turn that one over. Are you with me? Proportionally the same as. Okay. You're going to get exactly the same answer. When you cross multiply, you're going to have 57 times x, and you're going to have 100 times 8410. But you do not need to flip those over. Come back to the original problem. Do you see that you can just ignore that third line? You've got your 100 is to 57, proportionally the same as the x is to 8410. Okay. Let's finish this one then. If I know that the number that x is $147.54, how can I figure out what the new amount is? Absolutely. I can take $147.54. I can subtract $84.10, which is the amount of change, the amount of decrease, and I will come up with the new amount, which, who's done that in their calculator? 63.44. Okay, I want to do one more thing to maybe clarify what else we can do here, okay? Let's say that I did not want to come up with new in that example. I did not want to come up with the old. I just wanted to come up with new. Come back to these original 3 lines. I could have said 57 is to 43. Do you see where I'm coming up with these numbers? Proportionally the same as 8410 is to x. When I cross multiply, I would come up with 63.44. The powerful thing about proportions is as long as they're set up correctly, and you've got numerators that both represent old, and then denominators that both represent change. As long as the things that are in the numerator match and the things that are in the denominator match, you do not have to set them up like those percent problems. And I know we did not do an example where we were given change. And again, as we worked problems after we turned off the tape yesterday, a couple of people saw this one and said, wait just a minute, how do I do it? You can use any 2 of those 3 lines to set up a proportion, and you will, as long as you have 3 of the numbers, you'll find the 4th number. Had I found the 63.44, I could have added it to the 84.10 to come up with my old amount. Christine, did that answer your question?
Well, I think I was thinking it would go on as a decrease, the way you showed us to set it up with the 100 first.
Using the percent.
And then it would go on the bottom.
Right. And again, you can flip them over as long as you flip both of them over, both sides of your equation. But you don't need to. You can set them up proportionally just exactly as they come off the model. Yes? And this is
I have a question
Kari?
on number 27.
Is it,
What?
is this Kari?
No. Cassandra.
Cassandra.
Yeah.
That's Kari back there. You guys both have long dark hair. Yeah. Okay.
I have a question on number 27.
On page,
55.
on 2-4 again?
Yeah.
Okay. Let me move my paper. It says interest rates dropped a 0.5 percentage point to 7.25%. What was the percent of decrease? We're going to once again start out with the old change new. These are great questions. I'm going to put value over here instead of money. Is that all right? Because that column can represent not just money, but some sort of value. We're always going to put 100 by old. What is that 7.25%? Does that represent old or change or new?
The new.
It represents new. Interest rates dropped 0.5 percentage point. and the new is 7.25. So what I'm going to do, I'm going to switch to red, and over here I'm going to put 7.25. So that's my new value. How much did it drop? I know this change was negative. Half a percentage. How would I write a half a percentage so that it would work in here kind of nicely? 0.5. And it goes over here under value. Is that all right? When it dropped a half a percentage point, the value fell. That happens often with loan rates where they go up or down a 0.5% or 0.25%. Is that right? So what was the original or old value if it dropped 0.5 or 0.50 or a half a percentage point, and it currently is 7.25? 7.75. That's right. Cassandra, does that make sense now?
Yeah.
Okay, what are we looking for then? What is the problem actually asking us to find?
The percent decrease.
The percent of decrease. So where we're going to put our X is right there. Is that all right? We do not need that new line at all anymore. We can ignore it. I can set my proportion up going 100 is to X, proportionally the same as 7.75 is to 0.50. I can use 0.5 or 0.50. I have a tendency to keep all the decimals the same length. I'm then just going to, once I've got that proportion set up, cross multiply. Who's got their calculator and already got it in there?
6.45.
So the amount of change was a decrease of 6.45%. So a 0.5% decrease represented on a basis of 100 being the original 6.45. And that's the confusing part about dealing with with percentages on both sides. You've got to keep track of did it decrease a 0.5% on the percent side or a 0.5% on the value side? And that 0.5% decrease was on the value side. It was looking for the percent of change. Did that clarify your question? Yes.
I have a question on number 11.
And I think this is, excuse me?
Are you asking?
No,
my name?
I'm thinking, trying to think of your first name. Is this Josh? Okay.
I've just got a question where to put, because I know how to get X. I just don't know where to put the answer on the old or the new.
In which problem?
11.
On the, oh, it wants both answers.
Okay.
Let's
Yeah,
flip over the page and let's set it up. That's going to show through. We're talking about number 11 in 2-4. We've got old, we've got change, we've got new. Under percent, we know that it doesn't tell us whether that change was an increase or a decrease, does it?
Well, yeah, because the new's 46%, so I figured it was probably a decrease.
Oh, very good. It had to have been. You figured that out. Good. Okay, so we knew this was 46. Since it was less than 100, it had to have been a decrease. Good analysis. 100 goes here. Does everyone see how he knew that was a decrease? Okay. And what else do we know? This is 775 on the dollars. Yes? Did you use your calculator to figure out what percent of change we had?
Well,
I need this
yeah,
number.
64, yeah.
No,
54.
54, that's right. 54 goes there. You're asking the question, am I supposed to come up with old or am I supposed to come up with new? And the answer is both of them. When you set up a proportion you're either going to come up with old or come up with new. Once you have old, you can subtract $775 to come up with new. Or if you come up with new, you can add $775 to get old. What proportion did you set up, or did you get it started?
54x equals.
Okay, you put the X here. Is that right?
Well, let me see.
You said 54.
No, I put the X up top.
Okay.
Kinda old. Yeah.
Said no, no, no.
Yeah, I guess you could do either way.
You can do either way. I think that's confusing when you have options. Okay.
54x.
All right, so you put 100 is to 54, proportionally the same as X is to 775, and you ignored new.
Yeah, but I've seen now that x is the old.
X is the old. You kind of have to put the X where you want it to be. What did you get as old?
$1,435.19.
Say those numbers slowly.
435. 19.
Good. And we need you to come up with new, but you don't need to set up a second proportion in order to do that. If you have the original or the old amount, you have the change and you know whether it's a positive or a negative, and this change is a decrease. You're going to take your $1,435.19, subtract $775, and you're going to be able to do that calculation and come up with new. Who has that number? Quincy.
I don't have a question.
Oh, I thought you had the answer.
Yeah.
660.19.
660.19. Right, and we got that by simple subtraction. However, if we had chosen to, we could have done 54 is to 46, proportionally the same as 775 is to x, cross multiplied, and we would have solved for new directly. So in answer to the question, which one of those am I supposed to come up with, it's both of them.
Right.
And you should be able to look at the proportion to figure out, to begin with, which one you're solving for. Is that okay? Who's got another question? I'm so happy everyone's doing their homework.
And now you said you want to go out as many decimal points as the problem shows. Is that how you want us to do? Because some of these...
I'm saying generally we're going to round to the nearest hundredth. We're generally going to round to 2 decimal places. That kind of has a tendency to be plenty. Usually on tests I'll go ahead and round your answer to 2 decimal places so we're all talking the same.
So if the problem doesn't have a decimal point in it, but the answer possibly could, how far out?
2. I'm happy with 2. And someone asked the question the other day, how are we rounding money? And generally, let's round money just the way we normally round decimals. If it's followed by a 0, 1, 2, 3, or 4, let's round down. If it's a 5, 6, 7, 8, or 9, let's round up. But in reality, whoever said that one, you know, if oranges cost 33 1/3 cents, you're going to pay 34 cents for them. I mean, that tends to be the tendency, and I'm not certainly going to be picky about that, but I think we should round according to just good techniques in this course. And if you've ever got a question about where we're rounding, ask, and I'll give you my opinion. And different people, we're talking a penny one way or the other, probably have different opinions, but that's mine. Who's got another question? I'm so glad that you're choosing to do these the way they do them in the book. I think it gives you the big picture of all of the parts. When we're talking about percents of increase and decrease and seeing the old, the change, and the new, I think it does give you an overview of all the parts of what's going on with the problem. So comments about, do you like that model? Seem okay to work with once you got used to it? Good. I think it's the first time I saw it, I was very, very, very impressed. And the more I teach this method, the happier I am with using that, because we're going to use it so much more the rest of the semester. We're going to, lots of situations we're going to put into that proportion model. Ready to talk about 3-1? Yes. Who's ever had a salary or a wage?
Everybody.
Everybody, we hope so. Not my personal children, but I'm working on that. I keep saying to my kids, have you figured out what you're going to do this summer? Anyway, we're going to do this section on wages and salaries. We're going to talk about hourly wages to begin with because they're the most straightforward, least complicated. Most of you have probably had experience both with making an hourly wage and being paid overtime. That's the first topic. And then we're going to finish up the hour talking about wages that are in other pay periods besides by the hour. Okay? We have on our handout got a payroll ledger there for two people, very uncreatively named Smith and Jones. There is a definition there that says when you want to calculate gross earnings for an employee who is getting paid hourly, what you're going to do is multiply the number of hours worked by the wage per hour. And I think that's something that you probably were comfortable with before you came here today. So we're looking at this, and it says on Sunday, Smith worked 6 hours, Jones worked 4 hours. Are you seeing what we're doing? What I need you to do is get out your calculator and come across and tell me the total number of hours worked by each of those employees. On the chart itself, it tells you what their hourly wages are, and let's calculate some gross wages for both of these people. Take a minute and tell me how many hours Smith worked during this week, and tell me how many hours Jones worked this week. Somebody that's got the answer, yell it out. Smith is 32.5. Anyone agree? Yes. Okay. What about Mr. Jones or Miss Jones? 36.5. Great. We're looking there and seeing that Smith makes $5.65 per hour. So what we're going to do is give him credit for 32.5 hours times $6.5 or $5.65. Put that in your calculator, and you're going to find out his gross earnings before taxes are $183.63. Do we agree? Great. And Jones worked 36 and a half hours. He's making $6.18 an hour. We're going to calculate and come up with gross wages there of $225.57. As a preview of what's to come in later sections, we're going to take those amounts and we're going to take out all the taxes, and we're going to prepare payroll ledgers and figure out what their net earnings are, what they're actually going to take home. We're going to figure out what their checks are worth, because you know you don't take home all of your gross earnings. No. Okay. Problem 2. New exciting name, Johnson. He is paid $7.50 per hour, and he gets time and a half for all the hours he worked over 40 hours per week. We're going to find his gross earnings, and we're going to give him time and a half for hours over 40. So we come down, and there's Johnson's payroll ledger. Take a minute, add those up. Let's talk about how many hours he worked. Anyone agree? Fran's saying 46 hours. Okay, we have two different ways of figuring out what those gross wages will be. It kind of depends on how you see it. I'm always amazed because one of these ways is the way I would do it, and I'm amazed when other people see it other ways. I'm going to show you both of them. Total hours are 46. Let me get on the paper here. I personally like method 1, but method 2 is very appealing to a lot of people. You would take the 40 hours that he works, he gets $7.50 per hour, and his regular hour pay would be $300. Then he would have 6 hours of overtime. How would I come up with what his overtime wages would be? He gets 1.5 times $7.50. Overtime hours are paid at a rate of $11.25. Yes, so you'd extend that by taking 6 times $11.25, getting $67.50. Add those two up, and I find that Johnson's gross wages are $367.50. Another method is to give credit for 46 hours of work at $7.50 an hour because he gets paid $7.50 for every hour he works. For the additional 6 hours that he worked overtime, he gets a bonus of $3.75 per hour. That $3.75 represents the 0.5 times 7.5. Again, we're going to then get overtime bonus of $22.50. Add them up, it's the same paycheck, $367.50. Method 1's sort of the way my mind works. Method 2 is the way that a lot of people think about it too. Whichever way is comfortable for you is fine with me. You're going to be needing to look at a payroll ledger and figure out gross earnings with and without overtime. Next topic. A little different thought. This time Johnson is getting paid time and a half anytime he works more than 8 hours a day. Doesn't matter how many 8-hour days he puts in a week. He could do 7 8-hour days. As long as he didn't work more than 8 hours a day, he doesn't get overtime. He only gets overtime on the days that he works over 8 hours a day. So you need to go back up to the chart and tell me how many regular and how many overtime hours he's got. Because it's different.
Does he get overtime for every hour over?
Over
Yeah.
8.
But not, like, if he works over 8 hours in one day, he doesn't get, like, 9 hours of overtime.
No. No, I understand your question. The overtime only comes after 8 hours a day. It's just another way of figuring wages. It's just a different look at the same topic. So how many hours? He's worked the same 46 hours, but how many overtime hours would he have? The only overtime hours he would have would be on Monday, 1.5. So we're going to use exactly the same technique that we used before. We're going to figure out how many regular hours of pay he's got, how many overtime. How many regular hours of pay would he have?
44.5.
Yeah, 44.5. You can take that times the 750. Quincy, do you understand what we're saying? He
Yes.
doesn't get paid overtime except on days.
That he works over 8 hours.
Right.
I understand.
So he would have 44.5 hours that he gets paid regular pay. So do those calculations and tell me what you're coming up with. I can tell that that blue wasn't a good idea. It's not showing up.
I got an hour and a half on Monday
And nothing else.
and nothing else, so that equals $18.
Ooh, you need to get your calculator.
I'm off.
Who's got, I've got that 46 hours were paid, and I think I did that one wrong, maybe. No, I didn't. I did 46 hours were paid at $7.50, and the last hour and a half, he got the $3.75 bonus. That's doing method 2. So he ended up with $350.63. If you did the other method, you would have, and I must not have done that one, you would have 44.5 times the 750, and then those other hour and a half you would see that as 11.25, and you should end up with exactly the same gross wages. Questions, or is that all right? The next topic tends to be a vocab lesson, and it's kind of important that you think about what the words mean. Sometimes people don't get paid hourly. I don't get paid hourly. I get paid every 15th of the month and the 1st of the month. 15th of the month, 1st of the month. Does anyone know what that's called? Semi-monthly. I get paid every half a month. How many paychecks is a person who's employed for the entire year going to get if they are paid semi-monthly? I'm hearing 24, I'm hearing 26. And this is the confusing part. Okay, if you're paid monthly, if you get paid once a month, every month, how many paychecks would you get a year? 12. If you get 2 paychecks every month, like the 1st and the 15th, how many paychecks would you get? 24 paychecks a year, right. Semi means half. Like a semicircle is a half a circle. What's the name of the pay period that people would get 26? Bi-weekly, that's right. It's every other week. How many weeks are there in a year? 52. So if you get paid weekly, you would get 52 paychecks a year. If you get paid like every other Friday or every other Thursday, and it hasn't got to do with the day of the month, not the 1st and the 15th, but it's got to do with that you get paid consistently like every other Friday, then you're going to get 26 paychecks a year, and that pay is called bi-weekly. Bi meaning 2, like bicycle means 2 wheels, means 2 weeks. Semi means half, in a half a month, okay? So the key in being successful when you're doing these and getting these conversions done is that you understand the difference between semi-monthly and bi-weekly, because those are the 2 hard ones. Everyone else the rest of them seem to take care of themselves. Okay, so we've got those defined up here. How many paychecks per year that you would get? So we want to talk about Jones for a minute. He gets paid $572 per week. I want to know, to be able to convert that to per month, per year, per a semi-monthly and a bi-weekly pay period. Is that okay? So let's talk about what we're going to do. If he makes $572 a week, which one would be the easiest one of these to do? We're not going to do these in order because we can't. Per year. Good. If I wanted to figure out how much he made per year and I knew how much he made per week, what would I do with that 572? Take it times 52. Very good. That would give us his annual salary. I want to point out again, we can't do these particularly in order. It's easier if we don't do them in order. Okay? So what did we get as his annual salary? Good. $29,744. Very good. Let's go back now to per month. If I wanted to know how much he made per month, can I take his weekly salary and multiply it times 4? No. That's the most common mistake, and you cannot do that. A weekly salary does not become a monthly salary by multiplying by 4. You must take that weekly salary, multiply it by 52, and then divide by 12. I'm not doing them in order. Does anyone want to talk about that, not multiplying a monthly one by 4?
Not every month.
4 weeks. That's right. It wouldn't be enough money. If you took 572 and multiply it by 4, you would not get that per month that we've got there. Great. So how are we going to come up with the hourly rate? And we're assuming that the person that's doing this work is working a 40-hour week. Divide what by 40? Yes. Take the 572 and divide it by 40. We're assuming this is a 40-hour week. When I take the hourly rate, I get $14.30 per hour. Is everyone tracking? Good. Bi-weekly means every 2 weeks. So I would take the weekly salary and multiply it times 2. If I was paid weekly, it would give me 52 paychecks. And if I just took that same amount and multiplied it times 2, that would tell me what the paychecks would be that I got 26 times a year. Last one we're going to do is semi-monthly. Semi-monthly, I want to find the monthly amount and then divide it by 2. Or I can take the annual amount, which I'd get by multiplying by 52 and divide it by 24. Kind of depends on what other figures I have. Is that confusing or does that seem clear? Okay. We're going to go ahead and do another example then. And your homework's going to look like that. We're going to give you salaries based on a certain pay period and say, let's convert those to all of the other kinds of pay periods. So if you were working on a payroll in your own business or something, you could tell someone what they made per hour, what they made per week, what they made per month, any of those pay periods, right? Okay. Next example then. Take a minute and work on these. I'm going to try to scoot these. In this particular case, hold on. No, wrong direction. I think this one's a little more straightforward. It's actually easier than the last one. It says Smith makes $31,151 per year. Well, we want to come up with monthly, weekly, hourly, biweekly, and semi-monthly paychecks. I'm going to give you a minute to see how those are going. See what your numbers look like. Who's shaking their head back there? What's... Christine, help us with one. Which one's easy? Take $31,151 a year and convert it to one of those. She said, if I wanted a monthly amount, I could divide by 12. Great. What'd you get when you did that?
2595.92.
2595.92. If I've got yearly and I want to go to monthly, monthly would be 12 paychecks a year, divide by 12. Very good. Okay. Kari, do you have a calculator? Which one did you do? Or which one can you do? You got them all. Give me one. Give me one that's more difficult, maybe.
Per hour is $16.22.
How'd you get per hour?
I divided the week by 40 hours.
Well, maybe what did you do to get weekly?
For the week, I got $648.98.
Okay, I think that's the one that's not right. How are we going to get weekly? Take the total and divide it by 52. What number did you divide by?
Probably.
Well, and maybe your fingers just touched the wrong button.
That's a good possibility.
Okay, let's go to weekly first then.
Yeah, I did.
Okay, I think you just punched the wrong button. What did we get for weekly?
$599.06.
Great. We took $31,151, divided it by 52 weeks, came up with a weekly paycheck of $599.06. Great. And now you're right. To come up with the amount that we would get paid hourly, we would take our weekly wages, divide it by 40. We're assuming it's a 40-hour week. That's the most common work week. And when you did that, what did you come up with this time? Great. Keegan, do you have one of those other two? Okay. How about you, Karen?
The semi-monthly.
Semi-monthly. Okay. What did you do?
Well, I did a little different than you did.
That's all right. There's lots of ways to get the right answer.
I did the month and divided it by half, and I came up with.
Great. She said, I took the monthly salary, realized there was going to be 2 paychecks per month, and I divided it by 2. I took the yearly salary and said, you're going to get 24 paychecks and divided it by 24. Both ways are right. You're going to get the same answer. Okay? And what are we going to do with bi-weekly? take the week and divide it by 2, that's good. Or if I had the annual one and I wanted to go directly,
Divided by 26.
yeah, I'm sorry, you're right. Take, I was ahead of, I was behind you a little bit there. Take the weekly and multiply by 2, or take the
Yearly and divide it by 26.
take the yearly and divide it by 26. Generally, people are very good at coming up with those that have to do with months, with weeks, with hours. The ones that tend to give people problems, they tend to reverse the semi-monthly and the bi-weekly. So make sure that you get straight which is 24 and which is 26 by thinking what the words mean. Semi means half a month, so it'd be 2 in every month. Bi-weekly means 2 weeks, every 2 weeks. Okay? All right, are there any other questions about what we've covered today? If not, I'm going to have him stop the tape. We're going to start on homework. Is that all right? We've got about 8 minutes here, and I'll come around and help you.